let's do some integrals here. Hopefully this is a review for the stuff that you've covered in a previous course, but that may or may not be true. You may not feel comfortable, so hopefully this review will be somewhat helpful to you. The first one we wanted to do while finding this integral is the integral of 19x minus 8 to the 20th power dx. So we're going to use a u sub here. In fact, we're going to use a u sub on all of these. But what I do is I say, okay, well, I'm going to take u to be what's inside the parentheses here. So u equals 19x minus 8. So du equals 19 dx. So we take the derivative, we have 19, and then that x, it's just derivative of 19x is 19. Derivative of negative 8 is 0, so that's how we get 19 dx. But we don't have a 19 dx, we just have a regular dx. So I can then say 1 over 19 du equals dx. So now I have this piece and this piece that I can sub in for. I have u to the 20th times 1/19 du. So now I can use the power rule, right? I have something to a power, so I can say, all right, well, I can add 1 to the power. I can say, all right, u to the 21 over 21 times 1 over 19 plus c. And then what I can do is I can, I started with x's, not in u, so I have to replace that. I'm going to say, all right, that's 19x minus 8 to the 21 over, I believe that's 399. Plus c. So simple enough on that. We just plug in u. Our next one, we have 5 over the square root of x and times 11 minus 2 square root of x dx. So in this particular case, what we want to do is we want to, we're going to take u as what's inside the parentheses, and it's not the only thing way we could have done it. We actually could have done it with sort of a chain substitution, but that's pretty nasty, so I wouldn't recommend that. But before I do that, I'm going to rewrite this in a few convenient ways. So what I know is that the square root of x is actually x to the 1/2 power. So I'm going to write that as 5, or x to the 1/2, 11 minus 2x to the 1/2 dx. But I actually don't even want to do that. What I want to do is I want to take this and pull that into the numerator. So if it has a positive value in the denominator, it's going to have a negative, positive exponent in the denominator is going to have a negative exponent in the numerator. So I'm going to have 5x to the negative 1/2 over 11 minus 2x to the 1/2 dx. So what this is going to allow me to do then is I can take u as my denominator here. So I'm going to say, all right, u is 11 minus 2x to the 1/2 power. So du, so if I take the derivative of 11 is 0, it's a constant. So then I have negative 2, bring down the power, subtract 1. So if I have a half and I take away 1, end up with a negative 1/2 dx. So those cancel, the 2 and the 1/2. So that's negative x to the negative 1/2 dx. If I pull the negative over, though, I can say negative du is equal to x to the negative 1/2 dx. Well, looky there. I've got x to the negative 1/2 dx already. So then I can replace this. I can say, all right, well, that's integral of negative 5. Right, we have that negative on the du. And on the bottom, I have a u. Well, that I can rewrite that as a negative 5, 1 over u du. Well, that's that natural log case. So I have negative 5, natural log, absolute value of u. Got to watch out for that, absolute value of u. Plus c, at which point I didn't start with u's, I started with x's, so I got to go back to the x's. 11 minus 2 square root of x plus c. Alright, so that is another way to do, or that is a way to do that. The next one has a couple of different ways. So that I want to do two parallel paths here. The first one is to do kind of the naive way, the way that kind of makes sense and probably should be done this way, but I'm not going to do it that way. All right, so I have 4 cosine 2x times e to the sine of 2x dx. So what I want to do here is a lot of times taking that exponent by itself as u is the right way to do it. We're going to say u equals sine of 2x. So du, by the chain rule, so the derivative of sine of something is cosine of the something times the derivative of what that something is. So it's not just cosine of 2x. We change
According
the
to
derivative
Wikipedia,
on
the
the
derivative
inside.
of a function
Are you
y
serious?
equals f of a variable x is a measure of the rate at which...
Are you serious? Like that's ridiculous. I'm going to leave that in because it's funny. At least it is to me. It's ridiculous. Don't do this stuff with your phone in your pocket. Come on, man. So we have cosine of 2x. We chain it with 2 here. And then we have dx. So du is actually 2 cosine 2x dx. Okay, great. Good, great, grand, wonderful. But I have a 4 here, so I could just say 2 du is that. That's fine too. So I have a 4 cosine x dx. So that's one grouping. And so I can replace that with 2 du e to the u. Right, I have 2e to the u du. Now we know the antiderivative of e to the u is e to the u. So I'm going to say that's 2e to the u plus c, 2e to the sine 2x plus c. Simple enough, right? Not a problem. That's probably the way you should do it. I want to be a little more clever just for funsies. What I'm going to do is instead of taking u to be this, I am actually going to take u to be the e function here. The reason why I want to do this is because sometimes it's helpful to kind of push yourself a little bit, and sometimes surprisingly taking a bigger thing prevents you from having to do multiple substitutions, because sometimes you have to do multiple substitutions. So let's do the case where I say u is equal to e sine of 2x. Now what this is going to do is this is going to make my chain rule a little more difficult. So I'm going to say du. So the derivative of e to something, remember the derivative of e to something is e to something. Sorry, 2x. So it's e to something times the derivative of that something. Times the derivative of sine of 2x. Well, we just got that over here. So that's 2 cosine 2x dx. So then in this particular case, what I can do is I can say, all right, well, I don't have a 2, I have a 4. So I can say that's 2 du equals 4 cosine 2x e to the sine 2x dx. Which is funny, right? Because this entire expression here is that entire expression there. So my substitution actually doesn't involve u at all. It just has this 2 du. So I have 2 du. Well, the antiderivative of a constant is the constant times the variable 2u plus c. Now I use my substitution 2e to the sine 2x plus c. So I get the same thing, right? That's the whole point is that you get the same thing. It doesn't matter which way you do it. But remember that you have some choices here. You can use some cleverness to arrive at the correct answer.